record. All right, here we go. So today we're going to start hypothesis testing, which what you'll find is that there are a lot of steps that we need to remember what to do next, okay? And so what I want to do is start by giving you an overview of what we're going to be doing, okay? So not get into the nitty-gritty of every step, right? So we're just going to look at what the process is, okay? And then we're going to go back over it and fill in the blanks with an example, okay? Remember, you won't be able to do this example because I haven't shown you what to do yet, right? But that's how I'm going to develop the ideas. Okay. Good. So section 5.3 is hypothesis testing. So like I said, just to give you a heads up here first, let's outline the general steps to hypothesis testing, right? So when you go back and you look at these notes, you're not thinking, this is all she gave me? No, but we're gonna just outline the general steps. Outline the general steps. Oops. To hypothesis testing. Hypothesis testing is when we want to show that something is significantly different from a number or from each other, right? And so, for example, if I wanted to prove that Obama's going to win an election, right? Then what am I really testing? I'm going to use a sample proportion, right? And I'm going to prove that it's significantly higher than 0.5, right? You need more than half the votes in order to win, right? And so that's going to be hypothesis testing. Yeah? So, but just so that you are aware, then we will go back and fill in all the details. And fill in the details. Okay. Hypothesis testing, I usually abbreviate HT because it's so long to write. Okay, so let's get used to that. And hypothesis testing will always follow, I make it 4 steps. You'll see, you can break it down into however many steps you want, but I think 4 is a nice number that we can kind of nudge us along, right? And so hypothesis testing will always follow these 4 steps. First step will be to state your hypothesis. Okay. Seems obvious. State the hypothesis. And even though it's nothing like what we're going to be doing, right? I remember in, I don't know, grade 9 science, we had to state our hypothesis, right? When I boil this water, it will evaporate, right? That was my hypothesis. I thought that was going to happen, and sure enough, it did, right? And so same idea, but now kind of more mathy, okay? We're going to need notation for the 2 hypotheses, right? So in that boiling water scenario, right, it either doesn't boil or it doesn't evaporate, or it evaporates, right? So we have this null hypothesis and an alternative hypothesis, we call it. So we'll always have these 2 hypotheses. If it's not one, we can conclude the other, okay? So the null hypothesis, we denote with an H subscript 0, and may or may not have seen it before. And I meant to look it up. I can't remember if H naught is NO UGHT or an A UGHT. So I'm gonna make an A that looks like an O and call it a day. No, I think it's O, H naught, or H null, or null hypothesis. It's a 0. So we're going to have a null hypothesis and we're going to have an alternative hypothesis. Now the null hypothesis is going to be a statement of no change. Okay? Now that doesn't really make sense right now, right? Where with the boiling water example, right? If I boil water, it does not evaporate, right? Then there's no change. Whereas I actually think that it will evaporate, right? That's my alternative. Yeah. But your null hypothesis is a statement. So you're going to use a colon here. All right. So here is my null hypothesis. So it's not an equal sign. It's a colon. It's a statement of no change. Okay. In terms of our voting example, right, that would be, okay, if I want to show that it's more than 50%, well, then I have to show that it's either less than or equal to 50%, right? Or we're just going to use equals just for simplicity's sake. In 240, we'll kind of adjust some things and we'll consider the other side of the statement. But we're just starting. We're just little. No. But for this reason, so it's a statement of no change. So for that reason, it's going to have an equal sign. So what's nice about your null hypothesis is that it's always going to have an equal sign. Okay. So H naught will always have an equal sign. Now, I'm going to make these steps as generic as possible because what we're going to do is we're going to apply these steps not just to one sample proportion, 2 sample proportions, more than 2 sample proportions. We can also do it for 1 sample mean, 2 sample means, more than 3 means, or more than 2 means. I skipped a category, right? So we're going to be able to apply these steps to lots of different types of questions. Okay, we're just starting with 1 sample proportion. Okay, which is the same as what we did with the confidence interval just yesterday. Our alternative hypothesis, I use H subscript capital A, you could use lowercase a, you could use 1 if you want to use 0, 1. There's lots of options. Okay. But you just read it as HA. Or the alternative hypothesis. Okay. Or you can write H1 or H lowercase a if you want. They're all the same. Pick one that you like. I like capital A because I call it the alternative hypothesis. Now, the alternative hypothesis is usually, not always, but usually the thing that we want to prove. Okay? And so if I want to show that the proportion of people who are going to vote for this candidate is more than 50%, right? That's what I'm hoping to show. But first, I would have to assume that it's 50%, and then unless I find proof otherwise. Okay, so HA is another statement, of course. And it's going to be, and maybe I'll say is typically just kind of I'm only being kind of picky about it because it's not always the case, but it's often the case. So typically, the hypothesis we want to prove without talking about metrics, for example, if I've developed a drug and I want to prove that it's better than this kind of established drug, right? First, I have to assume that they are the same until I have proof that mine is significantly better, right? So I didn't touch on metrics there, but right, was it a proportion? Was it a mean? I don't know, right? But the idea stays the same. Okay, so in general, this is what your null and alternative hypotheses are going to be. Okay, so you have to state your hypotheses, just in general. That's your first step. The second step that you're going to do is do the test. Seems cryptic. And in my mind, I read it as do the Mountain Dew commercial. Do the do. Do the test. Makes it cooler. Yeah. This is where we're going to calculate how far our sample statistic, or just our statistic, right, is from our hypothesized value. Okay. How can we do that in using something that we already know, right? A Z-score would do that, right? Tells us how many standard errors a sample proportion is from a hypothesized proportion. And that's exactly what we're going to do here, right? But I'm keeping it generic because there are other tests or other calculations that we could do. But they all do the same thing. So here, you're going to calculate how far the statistic is. Oops. How far the statistic is from the null hypothesized parameter. From the null hypothesized parameter. Okay. What does this, right? Because I'm comparing my sample information to my null hypothesized parameter, right? And so this is what tells me that, okay, I'm going to do all my testing assuming the null hypothesis is true. Yeah. And so here we do all our testing assuming H naught is true. And then what we're going to do is we're going to say, okay, well, if our sample statistic is far enough away from our null hypothesized parameter, then we're going to say, okay, well, then that's an unlikely parameter for this group, right? And so then I can reject it in terms, in favor of the alternative hypothesis. But I'm getting ahead of myself. So the reason I call it do the test is because when we do this, we're really calculating, so calculating how far the statistic is from this null hypothesized parameter. So what I'm going to do is I'm going to generate what we call a test statistic. Okay, so a Z-score is a test statistic that we can calculate, and we will calculate. There are others that we can calculate. We're going to move on to chi-squareds. We're going to look at T's. We're going to look at F's, right? All these different things that we could calculate, but they all do basically the same thing. They figure out how far your sample is from the null hypothesized parameter. So doing the test generates a test statistic, which I always have a hard time saying. Doing the test generates a test statistic such as a z-score. And that's the only one we've seen so far. But we'll add more to that list as we go, right? But for now, we've only seen the z-score, and that's fine. What's nice about z-scores? We know how to use them to find probabilities, right? Probabilities are areas under the curve. Oh, not that old gambit again, huh? I know, it's almost like there was a reason I made you do that. Reporting how far your statistic is from the null hypothesized parameter, that's not going to get you very far. Your boss would be like, what are you talking about, right? And so what we do to be able to communicate our results is we convert that to a probability, and that probability is called a p-value. Okay. So step 3 is find the p-value. Okay. Now what I want to do here is I want to write out the definition of the p-value, and then for the first, I don't know how long, you'll have to rely on just memorizing the definition of the p-value until it clicks. Okay. For me, and I'm going to be honest here, it wasn't until I was studying for the final exam that I was like, oh, okay, I get it now. So if it takes you a little while, that's totally fine. Or maybe it just clicks right away. That's great. Right. But in the beginning, let's just memorize what the p-value is, and then it'll fall into place later. Okay, hopefully. No, I know it will. Maybe even a little bit before your final exam. That might be nice. All right. Although it worked out for me, I guess. So the p-value is going to be the probability. So of course the p-value is a probability. So the probability of finding an observation as extreme or more extreme than what you saw, assuming the null hypothesis is true. Okay, so let's jot that down, and then I want to talk about it a little bit. So it's the probability of finding a statistic. Right, let's be specific here. Remembering that a statistic is any information that you've calculated from a sample, right? That's from way back. And a parameter is the same thing, but for the population, because we're going to be using those differences quite a lot. So the probability of finding a statistic as extreme or more extreme, oops, spelled or with an E, changing the meaning completely, although it might be nice, or more extreme than what we found in our sample, assuming H naught is true. Assuming H naught is true. Oops. That doesn't look like true. So a probability, right? What helps is knowing that I have a z-score, which means I'll be able to use the z table to find probabilities, right? And so here, the probability is an area under the curve. Yeah. So it's an area under the curve. Of finding a statistic as extreme or more extreme, right? That's going to be moving into the tails, right? So from your your statistic, right? That's where you're going to draw the line on your curve. And then it's the area in the tails. That's going to be the area that you're looking for. So as extreme or more extreme means that it's going to be the tail areas. And I'm going to put the S in brackets because sometimes it's only one tail, or it might be both tails most commonly. Very cryptic so far. I know that. But there's a method to my madness. Seeing, at least for me as a learner, if I've seen all the material or kind of where we're headed, then it's easier for me to fill in the gaps, right? And so I don't think I'm alone in that. That's why I loved studying for a final exam. I felt like kind of throughout the term, I'm like, I don't know, do I get this stuff or not? And then the final exam, it's like, okay, got everything here that I could possibly learn. And just gotta do it. Fresh page here. Our fourth step, remember there are only 4 steps, is our conclusion, right? So now I can use this p-value, so this probability, right, of seeing something as extreme or more extreme than what I saw, right? And so then I can use that to draw a conclusion. Oops. Now the conclusion has 3 parts. I know that's rude, right? And so, but I just lump it in as a conclusion, okay? And you're welcome to break it up into 3 separate parts if you want to, okay? But let's start with what it is. So if the probability of finding something as extreme or more extreme than what we saw is small, right? And that was assuming the null hypothesis is true, right? Then that's going to tell me that, okay, well, that's evidence against the null hypothesis, right? If the null hypothesis was correct, right, then the probability of seeing what I saw should have just happened naturally, right? It shouldn't be a rare occurrence, right? And so then if that p-value, right, so they're all chained together here. So if the p-value is small enough, and we'll have a threshold for that, okay, but for now, if it's small enough, then we say we have enough evidence to reject H naught, okay? Because we say, okay, well, it's too unlikely to have happened just by chance. It could have, but it's unlikely. Right? So if the p-value is, and I'll put in quotes here, small enough, small enough, we're going to need a threshold, right? And the default threshold that we use is 0.05. Okay? But in general, we call it an alpha level, right? A significance level. And we can use anything. Some common ones include 0.1, 0.01, but 0.05 is our most common one. Just like the 95% confidence interval was our default confidence interval, right? Same thing, and there is a relationship, right? You're either in the central 95% or you're out in the 5% of the tails, right? But that's too much for us right now. So if the p-value is small enough, which really means less than the alpha level, oh, that wasn't a very good alpha for our first alpha here. Greek letters galore. But alpha's fun, right? It's just a little fish. Right? So the alpha level I'm trying to think if there are a lot more Greek letters that we do. I think so. Beta. Can't remember. Anyways, a lesson in Greek letters, I guess. That's math. So less than the alpha level, which is a significance level. How many brackets can I fit in here? Alpha level, which is a significance level. And the default alpha is 0.05. Oops, no period. A lot of questions will tell you use a significance level of 0.05 or 0.1 or 0.01. Okay. But if it doesn't say, then you use 0.05. Right. So if it doesn't say, just use 0.05. Okay. Okay, so if the p-value is small enough, right, so less than 0.05, then we have enough evidence to reject H naught. Okay. Then we have enough evidence to reject H naught. If I'm going to reject it, I should probably say what the alternative is, right? And it is the alternative hypothesis. So then I'm going to say I'm going to reject H naught in favor of HA. Once you've gone through all these steps, you're exhausted. And then you forget to tell me what the conclusion is in terms of the question, which is probably what someone's paying you to do, right? And so don't forget to state the conclusion in terms of the question. So then state, and you really, often we just reword the question as an answer, right? Yes, there is significant evidence, blah, 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 blah. So state the conclusion in terms of the question. This scenario, right, that we just outlined, this is what we say if the p-value is less than 0.05, right? But what if it's not less than 0.05? Well, then we just reverse everything. Okay. So let's use a different color here. Or if the p-value is less than alpha, nope. That's what we just said, greater than alpha. If the p-value is greater than alpha, we do not have enough evidence to reject H naught, right? Because if it's greater than a 5% chance, then it's probably just happened by random chance. And so we're willing to just say, okay, then the null hypothesis is, I'm going to say, is true. So then alpha, we do not have enough evidence to reject H naught. If I'm not rejecting it, then that's where I end, right? I'm not gonna not reject it in favor of HA, then we just pull the plug there. And then state the conclusion in terms of the question, right? Of course. So here, state the conclusion in terms of the question. So how I break up the conclusion, and the reason I say it's 3 parts in itself, is because the first thing that you're going to do is you're going to compare the p-value to the alpha level, right? Is it less than or is it greater than the alpha level, right? Then you're going to state your conclusion in terms of the null hypothesis, right? Depending on what the situation was in the earlier step, right? Do you have enough evidence to reject H naught, or do you not have enough evidence to reject H naught? Right? And then you're going to state your conclusion in terms of the question. So what I want to do here is just break up both of these, right? Where the first part is I compare the p-value to the alpha level, just generically, right? So here, part 1, compare the p-value to the alpha level. I'll use pink for this next part because it's important. The second part, right, is the conclusion in terms of the null hypothesis. It has to be in terms of the null hypothesis just because we did all our testing assuming the null hypothesis is true, right? So we don't actually involve the alternative hypothesis unless we have enough evidence to reject H naught. Then we offer, okay, so this must be what we're going with, right? But our conclusion here is always in terms of H naught. And I guess there. So the second part here is your conclusion in terms of H naught. And I'll put in brackets, since we did all our testing assuming H naught is true, right? So until we have proof otherwise, right, we just assume it's true. So since we did all our testing assuming H naught is true. So it has to be in terms of H naught, right? You either have enough evidence to reject H naught or you do not have enough evidence to reject H naught. One thing is I never, ever want you to say you accept a hypothesis. Why not? Why is that so irksome to me? Because there's a p-value probability that you're wrong, right? Even if it's really, really small, right? There's that chance that we are making the wrong decision, okay? And so here, I'll put it in red. Uh-oh. We never underlined mean face or straight face. We never accept a hypothesis, right? We have enough evidence to reject H naught, or we don't have enough evidence to reject H naught. There are errors that we could be making there, and there are names for those, and we'll learn those, right? But for now, let's just kind of live it up in just the steps, okay? And so I never want you to say that you accept a hypothesis. I will take marks off, okay? You've been warned. And why? Because there is a p-value probability of being wrong. I'm thinking specifically if I reject the null hypothesis and I shouldn't have, right, then that p-value is the probability of me being wrong. But if it's small enough, we're okay with that, right? But it can still happen. So you never accept anything. And then lighter fare, the one that everyone likes to forget, right? State your conclusion in terms of the question and state your conclusion in terms of the question. So your conclusion in terms, conclusing, that's a new word. Conclusion in terms of the question. So the conclusion has 3 parts, right? Which means it's going to be 3 marks, and it's one of those text boxes where you're going to write out your answer, right? And so, and then I mark it. So you definitely won't be saying accept, right? No, no, no. All right. There, that's it. No. There's a lot more steps in between, right? We've just given you the, or I've given you the general framework, okay? But this is how it's always going to be, right? So if we, I know in the beginning, it feels very uncomfortable, right? There's a lot of steps and it feels like you're memorizing everything, okay? But just rest assured that we'll be following the same steps. So by the 4th time that we do it, right, then it's gonna feel like, okay, pretty sure I know what comes next. Choke on my own spit. Classy. All right. So how I want to introduce the steps specifically for one sample proportion questions is I want to just start with a question and then we'll build it up. It's a little bit rude, right? Because you don't know what to do. You'll have to follow me, but
Quick question.
no, no, yeah, of course.
In the conclusion, when we state the p-value is small enough, is that a measure of extremeness?
Yes. So if the p-value, because the p-value is a measure of extremeness, right? Because what it's going to be is the p-value is going to be some area in the tails, right? Your p-hat is going to be out here. So if it's far enough away from, and I'm going to delete this because it's getting way ahead of ourselves, but it's good to, it's good to see, right? So then if the sample proportion is far enough away from the null hypothesis, then you say, okay, well, then I'm going to reject the null hypothesis. So it is a measure of extremeness. We like to make up words, I guess, in statistics. Goodness of fit. It's not made up, but does make sense. So now, right, so that's the end of the steps. These are the steps you're going to follow, right? Worth kind of pseudo memorizing, not really memorizing, but just kind of getting comfortable with those steps. Okay. So now we're going to apply these steps to a problem. We will apply these steps to a problem. And I guess I have to stick with this one. What happened this morning was last night I had picked out an example that I wanted to use. And then I got here this morning and I totally blanked on which one. So I just had to pick one pseudo randomly. But this one is fine. So it's one of the exercises from the textbook, getting enough sleep. Just read through it. 400 students were randomly sampled from a large university, and 289 said that they did not get enough sleep. Uh-oh. Conduct a hypothesis test to check whether this represents a statistically significant difference from 50%. Okay? And use a significance level of 0.01. Okay. We know sort of what's going on here. Maybe not all of it. But the first thing that we're going to do is we're going to just establish what type of question this is. It's easy because we've only covered one type, right? One sample proportion. So it's fine, right? We know it's going to be one sample proportion, but what's going to happen later is you're going to have to choose between all these different types of questions and identify what type of question it is. Once you know what type of question it is, then that tells you, okay, then I have to follow these steps and this is what I'm going to do, right? So it's arguably the hardest part. Okay. Now, so the type here is, of course, one sample proportion because we don't have any other options. But I also want to tell you why. Okay. Let's just consider how many samples did we look at? Well, there's only one sample of 400 students. And then we have some fraction of those that say they don't get enough sleep, right? And so the one sample comes from the one sample of 400. If it was two samples, what would it look like, right? We took a random sample of students at UBCO and a random sample of students at OC. And at UBCO, we found that this many did not get enough sleep. And at OC, we found that this many did not get enough sleep, right? Then all of a sudden we have information from two samples. So that's where we're headed. We will be able to solve those problems. But for now, just one sample. Okay. And it's a proportion, mostly because there is no mention of a mean or a standard deviation, right? And so that's our dead giveaway later, but it's also a fraction of the 400, right? We're told 289 of those 400 students did not get enough sleep, right? Making it a proportion. Usually I get carried away and I want to check the conditions. Right? Can I use a Z-score to find probabilities? Right? Luckily, the conditions stay the same, right? We have to have independent observations, and then we have the success failure condition. The problem is that the success failure condition now uses the null hypothesis or the null hypothesized value. So that means that we have to set up our hypotheses first before we can check the conditions. Okay. So let's.
Is it always a binary variable, success value, yes, no?
Yes. Yeah. And it's only going to be for proportions. Yeah. So in order to check the conditions, we need to state the null and alternative hypotheses first. And I'm out of time, I see, or I hear rather, the null and alternative hypotheses first. And that's where we'll pick up next day. So we'll keep going through this and we'll work through this problem and fill in the gaps. If you have any questions, let me know. Otherwise, have a wonderful weekend. See you on Tuesday. stop this recording here.